To evaluate the collective thinking, we often conduct psychological testing in small groups. Usually, participants respond to verbal questions. Their responses are processed in order to assess their abilities to work as part of a group. How a collective decision is made, what information exchange mechanisms are engaged by participants, how to measure collective thinking. Psychology doesn't offer any answers yet. The objective of our lessons is to explore the tools for collective thinking's evaluation. How to utilize the same stimuli, a game in our case, to test a collective thinking potential of any particular group. We are familiar with functional principles of vision, hearing, motor systems. However, we do not know anything about the mechanisms responsible for collective decision-making. The group almost always makes decisions more effectively than an individual. So, what is the collective thinking? We will explore it during this series of lessons. Now, let's imagine a group of 3 people and classify 3 groups of interaction between them. Decisions are made by one person, or dictatorship. Decisions are made by voting, or democracy. And decisions are made by each individual independently, anarchy. We can distinguish some more subtle group-forming mechanisms taking into account the way information exchange occurs between participants. Information exchange occurring during decision-making process. Or, information exchange is blocked since all participants are isolated from each other. All groups can be researched based on CTOR game decision-making model. There are 6 students in class and 3 players in a team, and there will be 10 possible pairs of team combinations. All combinations are presented in figure. The teacher controls the game through the admin interface, reshuffling the teams and changing the rules. Every player starts the game on the blank field. All members of the same team make their moves simultaneously. The competing teams move in the leapfrogger manner. The time allocated for each move is 5 seconds. Each combination out of 10 plays 3 games, and results are recorded in the final table. After 30 games, we identified 2 approximately equal teams which are highlighted in yellow. The team's assessment was based on the results achieved while playing against other teams. Their face-off game, the 2 teams started under different conditions. Namely, Team 1 was allowed to discuss strategy before the game, and Team 2 wasn't. Team 1 independently chose 2 winning strategies. First one, 2 players controlled the center and 1 attacks on the flanks, figure on the lower left. Second one player controls the flanks and 2 players attack at the center, figure on the lower right. As was expected, the game was won by Team 1. It is noteworthy that those winning strategies differ from those of a single player. Playing within a team requires a completely different set of skills. That became a real discovery to our students. Multi-CTOR program allows the experiment with collective thinking, changing the research parameters. Selection of team members. Allocating the time for a move from 30 seconds to 1 second. A special games format, disallowing watching the behavior of the fellow team members. The purpose of one of our experiments was to verify if the teams will keep winning if the time allocated for the move is reduced from 10 seconds to 2 seconds. The results displayed in the figure show that one of 2 approximately equal teams will demonstrate more abilities to think collectively than the other. For the last 30 years, the phenomenon of the wisdom of the crowds is actively utilized for prognostic purposes and in the complex decision-making process. However, we still have to find out how the collective decision-making is functioning without the info exchange between members. Multi-CTOR allows conducting such an experiment. All players are seated in different rooms without any way to communicate with each other and without even knowing who their fellow team members are. They see only red and blue chips in the field. The difficulty increases when the time allocated for one move is reduced. When it shrinks to 2 seconds, then the player's actions seem to be utterly chaotic. However, if the game's pace slows down, then you can see that one of the teams sticks to certain winning strategy. This experiment allows us to gather stats necessary to shed light on the mechanisms of collective thinking. We went over properties of the brain, the simplest model of the environment used in the game of CTOR, tested the cognitive processes used in the game, and finally took part in a series of experiments examining collective thinking utilized by small groups. Wrapping up the course, I would like to say, learn through play.